Alright, so this video is about skill 28, which is expanding and condensing logarithms. Let's start with an example of expanding a logarithm, which means we have a logarithm such as this one, log of x squared over y all to the 6th power. And our goal here, since we have one logarithm, we're expanding it so that our answer is going to have multiple logarithms. Our first step here is we're going to use our property of logarithms that allows us to take an exponent and move it into the front of the logarithm. So I can rewrite this as 6 times the log of the quantity x squared over y. Now if I look at this logarithm, the argument of the logarithm is x squared over y, and I see division taking place inside the argument. It's the quantity x squared divided by y, and I know that there's a property of logarithms that allows me to rewrite it as subtraction. So I'm going to write this as 6 log of the numerator, log of x squared, minus 6 times the log of the denominator, y. I now have one final step. I need to deal with the exponent on this argument, x squared, and so I'm going to reuse the property I used first. I'm going to essentially move this 2 into the front, which means I'm going to have 2 times 6, or 12, log of x minus 6 log of y. Now when we think about this problem, one common mistake I see is that students forget to multiply the 2 and the 6 when they move it to the front. Another common mistake would be forgetting to put 6 in front of each of the logarithms when we split it up. Remember, what we're essentially doing in this second step is when I have 6 log of x squared over y, what I'm using my property of logarithms on is really just this portion of it. So it's almost like I'm saying, alright, I can rewrite this log of x squared over y as 6 times the log of x squared minus the log of y. And then when I distribute this 6 in, that's what's going to cause me to have 6 in front of each of the logarithms, as I do in this step here. And so that's going to be my final answer here. Now let's do an example. Actually, I'm going to pause this briefly. Now let's do an example of condensing a logarithm. Let's say we have the log of z plus the log, it's the log 3 of z plus the log base 3 of x, and this is all divided by 2, plus the log base 3 of y, also all over 2. So this is our problem. We see 3 logarithms here all being added to each other, and when I'm condensing, my goal is to make them all into one single logarithm. So this is the reverse of the last step, or the last problem we did. I'm going to start, and what I'm going to do is I'm just going to think of these logarithms that are being divided. I'm going to think of them as actually having coefficients that are 1/2. So instead of the logarithm base 3 of x divided by 2, I'm going to think of it as 1/2 times the log base 3 of x. And the third and final logarithm, I'm going to think of it as 1/2 times the log base 3 of y. I'm then going to use the property of logarithms that allows me to take the coefficient of any logarithm and move it to be the exponent of the argument of the logarithm, which is going to give me this slightly simpler form. I'm going to have the log base 3 of z still, plus the log base 3 of x to the 1/2 power plus the log base 3 of y to the 1/2 power. What I'm going to do next is I'm going to use the property of logarithms that allows me to take any sum of logarithms, any two logarithms that have the same base that are added, and I can combine them by multiplying their arguments. So all of these are being added, so I can rewrite these as the log base 3 of z times x to the 1/2 times y to the 1/2. And you could stop there. There's actually one more step you can do. We can rewrite this as the log base 3 of z times x times y all to the 1/2. And remember, an alternate way you might see this answer written is you might see the log base 3 of z, and instead of x times y to the 1/2 power, you could see this written as the square root of x times y. So that's a quick summary of skill number 28, expanding and condensing logarithms.